Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome everybody. In this video, we are going to start with chapter 6 on the basic of PLC programming. In the previous chapter, we already learned about the hardware part of PLC and the main component of PLC system. Starting from this chapter, we focus more on the software component of PLC. So this is the aim and expected outcome of this chapter and also the references that we are going to use, which is programmable logic controllers. This is the hidden or the main content of this chapter. We are going to start with process memory organization, program scan, PLC programming language, bit level logic instruction, and so on until we end with the connecting with analog devices. So the first part of this chapter is more on the processor memory organization, and actually we in chapter 5 we already talked about the memory and the microprocessor of the PLC system, and we said the memory module is consist of or is included in the microprocessor module. And in this chapter, we are going to focus more on how the memory is organized after we learn the type of memory and the size of memory and their effect to the PLC performance. So actually we have mentioned or we mentioned in the previous chapter about the three type of addressing. We said slot based or like slot based addressing, tag based addressing, and PC based addressing, and we learn in which part or when we need to use each of these addressing type for the memory system. So here we are going to highlight some of this instruction or steps to use this addressing in our programming for the PLC, since it's more related to the software part of PLC system. So the first is rack-based memory addressing or slot-based. It's rack-based or slot-based. Okay, memory addressing, which is defined or derived using the rack number, and the slot number, and also the terminal number. So as you can see here, this we call it the rack of PLC system, and the rack consists of different modules of PLC. As you can see here, this is the rack, consists from the power supply module, the CPU module, and the other input-output modules. So this we call it rack. So when we talk about the rack or slot-based addressing, we are going to highlight the rack number and the slot number, and each one of this one we call it slot. So this is slot number 0, slot number 1, slot number 2, and slot number 3, 4, 5, 6. So we have slots from 0 until 6 here. So the number of slot also will be highlighted in the address, number of rack, number of slots, and the number of terminals. So each slot consists of several terminals here, sometimes 8, 16, depends on the size of the input-output model. So you can see here slot 0, slot 1, slot 2, slot 3, until slot 8 or slot 7 or slot 15, based on the size of address of the slot or number of terminals which will be connected to the input output models. So the tag based addressing, in the tag based addressing, it does not depend on the number of slot or number of the rack, but it's more on the tag, which is some names we are going to give for the component, like pump, switch, actuator, relay, and so on. So each part of the PLC component will be given an address or a name, and this name also is linked with some names which is generated automatically when we configure the PLC for the first time, as we already talked in chapter 5. So there is no fixed address or fixed area for the memory, because all the memory is just given based on the name or the alias of the name of the device. Actually, in the memory or the SLC 500 memory space, it will be divided into two main types of files. So we have data files and we have program files. The data files actually is based on the files or the data that the memory or the CPU will receive from the field devices, like the sensors, actuator, and switch, and so on. So this is more, we call it data files, and this data files is actually depends on what the data will be collected from the field devices. And the second part, we call it program files. And the program files is more related to the software that the programmer or the developer will develop for this PLC system in order to accomplish or complete some task. Okay, so usually we use some programming language to develop such program, and this program will be stored in the memory. And when we run our PLC system based on this software or this program, it will collect this data from the field devices like sensors, switch, and so on. The program files here is more related to the ladder logic program, and we said ladder logic program is the main software that or main programming language that we are going to use to program the PLC system, ladder logic program. And when we talk about ladder logic program, we are not going to talk about some type of coding, but we are going to talk about instruction, like you can see here. So this is instructions that we already highlight in chapter 4. So we have some instruction related to the input device, some instruction related to the output device, some instruction related to the to conduct some I mean to complete some task within the program. So this will be the program files that we will have inside our PLC memory. Okay, so this we call it the program files, and we can see here uh, if you already installed the software that I gave you for programming the BA system or simulating the BA system, you can see on the left side there is one folder, they call it program files or named program files. Under this folder we have some or several system files, and actually the program files will also include another files which is related to the operating system of the PLC, in addition to the software or the program that will be developed to run or to complete a control process over one or to accomplish one task. The data file actually, or the data of the other type of program of files, which is the data file here. The data file consists of several type of files like output image, input image, status, page, timer, counter, controller, integer, reserve, network, and so on. So all these type of files related to the data that will be collected from our field devices like sensor, switch, and so on for the input, and actuator for the output, and also in addition to some type of counter, timer, and so on, and different instructions that we are going to use within our program. So for the output here, it's more related to the output devices, which is actuator, and the input will be more on the devices, which is more on the devices for the input device like sensor, switch, and so on. And also we have some other files related to instruction that we are going to use, like timer, counter, control, integer, and so on. On these all types, each type of this instruction has its own file of data file. Okay. So this is the type of data file that we have. And usually the task of data file is to save the values of the information or to monitor the values of the status of the sensor and switch and actuator in the field. So when the value or the status of the device is changed, these values also will be changed. So sometimes it's zero, sometimes it will be one, depend on the data that will be received from the field devices. If the switch is on, for example, it will be 1. If the switch is off, it will be 0, and so on. This is the list of the data file that you are going to see in the simulator if you already installed. So on the left, you will see data files, and the data file, there is some cross references for indexing of the different data file. And we have output, input, status, binary, timer, counter, and so on. So each one, if you click, you are going to go to some files, and inside this file, there is some a list of bits. For each input or for each output, there is some values. For each instruction, there is some values. So the data files here are organized by the type of data they contains. So if it's the data is from input device, we call it input data or input file. If it's from output device, we call it output. If it's from timer, it will be timer. From counter, it will be counter, and so on. This is how the addressing is given to the some slots or some terminals based using the SLC family controller here, and we already see this one in chapter 5 when we talk about the addressing. So for example, if you have this address I1/2, so this is input address. Actually it is input. Since it is I, it is input. If it's O, it will be output. So we have here the separator, and then we have slot number. Slot number represent which slot is this. Slot number 0, 1, 2, 3, depends on where is the device is connected to which slot. Then we have the bit designator here, and the bit designator just to make slash to split the split number, to split the slot number from the terminal number. So then we have the terminal number here. This terminal number, it depends on these terminals. Actually, you have terminal, for example, this is consists of 16 terminal, start from 00 until 15 here, 1, 2, 3, 4, and so on. So this will be placed after the bit designator. It will be either 0, 1, 2, 3, and so on. If it's input, it will be input. If it's output, it will be output. So as you can see here, this is the terminal 11. So you can see here is terminal 11. This is slot number 2 output. So it is output slot number 2. This one is input slot number 1. So you can see input slot number 1. So this is how we can understand the addressing process of the PLC or for SLC family of microcontroller of controller. Okay, so this is how we can generate instructions and add the address for the instruction based on our requirement. So if it's input, we are going to take some input instruction with with input address. If it's output, we are going to take output address. So this one, it will be output, for example, it will be output to number terminal number 11. So from the left side here for the input output simulation for configuration, you are going to, after you drag and drop some instruction to your program here, you are going to add address. So the address you are going to take from this one, 0001 until, for example, 11 here. So you are going to drop to add the address. Since it is input, so it will, you are going to take the address from the input slot. If it's output, you are going to take the output or the address from the output slot. Actually, the SLC 500 is store data here table as in the form of the table. So you have input table and you have output table. So each terminal of your, each terminal which is connected to one devices, if it's input, it will be under the input table. If it's output, it will be under the output table. The status of this terminal or the status of this device will be indicated by or represented by the two words here. So this we call it two words. Each word consists of 8 bits. So when we say two words, that means we have 16 bits. Okay, so the 16 bits here will represent the status of our input. If you have one input number 0, so you go to the row input number 0. If you have input number 3, you go to the row input number 3. You will check the status of the sensor or switch from these bits. And then it depends, is it the input is discrete or the input is analog. If it's discrete, it will be represented by 1 bit only. If it's analog, so it will be represented either by 8 bits or 16 bits and so on. Depends on their values. If it's input, it will be under the input table. If it's output, so it will be under the output table. So here is one input model here. This input model, there is two switch connected to this input model. One is connected to this terminal number 3. One is to terminal number 7, for example here. So this consists from 8 terminals. So if you see the status of terminal number 3 here, it's the switch is open, so it will update the status inside the memory or inside the table of input will be 0. Since this is closed, it will give you 1 and so on. So this will be updated in the data table or in the input image data table. So it will display either 0 or 1 based on the status of the switch. If I close this switch, the status of this bit will become 1. And as I told you, this depends on if the switch is, if the input is discrete input or analog. Now, in this case for switch, it's discrete because it's only give you two values, either 1 or 0. This also the simulated how the status of the bits will be changed. You can see here this the status of the input will be changed either 0 or 1. If it's open it becomes 0, if it's closed it will give you 1. This for the input image or input data files. For the output is the same. When the output module receive the update from the mic from the processor or from the CPU, it will update the status of the actuator or of the output devices. Is it if it's a pilot light or if it's motor and so on. So this the data come from the output from the from the controller or from the CPU. It gave you, for example, in this one, it gave you 1. In this case, it gave you 0. The 1 will be sent to the slot number 5. So the slot number 5 will give the output to the pilot light here, and the pilot light will be on, while this 0 will be sent to the slot to the terminal number 1. This is 0 1. So the status of the terminal number 1 will be off here because it's here it received the 0. So based on the data, this 0 and 1 will be received from the CPU module, and it will be sent to the output module, and the output module here will send it to the actuator devices, whatever is the type of actuator. Is it analog or digital? So you can see here we have one output here at number 4. So you can check number 4 status is 1 here, 0 1. So the status of the output inside the output table will be changed from 0 1 based on the change here of the command that's received by from the CPU module. So this we call it the output table or input table. This is some of the fixed PLC that we mentioned, like in chapter 4. We said the fixed PLC, it has some discrete or analog input, discrete and analog output, and this number cannot be changed, just it will be connected to the device that we want to control. So for example, this model here, it has, or this controller has 20 discrete input with address I0 to I19. So you can see here from I0, which is I0 here, until A19. So it has 20 discrete input, and also it has 12 discrete outputs. So the 12 discrete outputs start from out 0 until out 11. Okay, so this we call it the fixed PLC type. We are going to continue in the next video.